This video is about metric conversions. I know a lot of us have difficulty with this, so to get you ready to be able to do some with me after I show you how to do a few, you need your equation sheet and a calculator, probably a piece of paper too. So I'm going to do one example and then I'm going to give you a chance to do one on your own. You can pause the video, work out the problem, and then come back and see maybe what you did wrong. Or maybe you did everything right. Anyway, metric conversions are just changing from one measurement to another. And it's by using conversion factors. And that might be what's causing the problems because maybe you haven't done this before. It's important, especially in chemistry, because you're going to use the same factor label method or conversion factor method later on with things that aren't metric conversions. So I put one on the board. 275 centigrams is equal to however many kilograms. So the thing here you have to be able to do first is tell the difference between the prefix letter and the base unit letter. So base units are going to be things like meters, which have a or a lowercase m, and grams, which have a lowercase g, or seconds, which is an s, or liters, which is a capital L. So you have to pay attention to those base units because they can be used interchangeably. The important part is the prefix letter. So the prefix letter is going to be a small m or a small c. You really have to kind of look at that in the problem and pick that out first. So when I look at this, I know that this is a prefix and that's a prefix. And this G stands for gram. And that's what the prefixes have been attached to. The prefixes are the important part. So when you look on your equation sheet, you're not going to see the G's. You're going to see the prefixes attached to something else, but they get to be used interchangeably. So because there are two prefixes, that means two steps, two conversion factors. We're going to go from centigrams to grams, and then from grams to kilograms. So the base unit is kind of like the stopping off point. You can go from centimeters to meters to kilometers. You can go from centiseconds to kiloseconds. The prefix is the important part. Whatever you attach it to, not so much. So when you look on your equation sheet, you're going to see these prefixes, and that's what you need to write down, or at least that's what you have to be able to use. So on your equation sheet, it says 100 centimeters is equal to a meter. And there's that lowercase c. But it's attached to meters, not grams. So if you want to, if it makes you feel more comfortable, change it to grams, because it means the same thing. You're going to do the same thing with the prefix for kilo. So you're going to go looking for the lowercase k. And when you see that, it says that, I think it says 1 times 10 to the third meters equals 1 kilometer. And if you want to leave that in scientific notation, that's fine, or you can change it to just plain old 1,000. Now, once again, we're not doing meters, we're doing grams. So if it makes you feel better, change it to grams. But this and this, those are the two equations that we're going to make into conversion factors so that we can change this around. So once you figure out which conversion factor or conversion factors you're going to have to use, which equations you're going to use, you need to set up your problem. And this is the part that I'll be looking at to see if you understand how to do this or not. You take whatever number is given, whatever measurement is given, and you put it over 1. That doesn't change how much it is, it just makes it into a fraction to make everything else easier. And then what I do is I put the conversion factors in parentheses. You don't have to, but I find it just makes it look more clean on my paper. So I'm going to make a conversion factor. I can't go directly from centigrams to kilograms, not with this method. So I'm going to go from centigrams to grams. So I'm going to use that equation first. And this is how I use it. The very first thing I do is I put the grams in the top part because that's what I'm trying to get in this step. I'm trying to get rid of centigrams. Centigrams will cancel out if I put another centigram down in the bottom of my conversion factor. This is kind of like in math class, if we had 2 over 3 and we were going to multiply it by 4 over 2, this 2 and that 2 would cancel out because one would be in the numerator and one would be in the denominator. It's the same principle, the same rule when you have letters or units. So this centigram will be able to cancel out that centigram. Do the units before you put the numbers in. So now you're going to use that equation to figure out where to put the numbers. In front of the gram is a 1, so that goes there. In front of the centigram is 100. That goes there. And then you just have to check, does the numerator equal the denominator? 1 gram equals 100 centigrams. That's what it says up here. So you've done this correctly. This first step will cause the centigrams to cancel out. For the second step, you're going to use the second equation. Make another set of parentheses if you want to. Like I said, this is what keeps mine, I keep it organized this way. So now I'm going to change from grams to the kilograms that I want. And that's what this equation is for. There's grams, there's the kilograms. Well, I want to get rid of the grams, so just like the first step, the gram goes in the bottom. I want to get kilograms and have that left over, that goes in the top part. Then I use my equation. What's in front of the kilogram? A 1. What's in front of the gram? 1,000, or 1 times 10 to the third. That makes the grams cancel out. Now I just have to do the math. If you're good with exponents, you can do it in your head. If you need to use your calculator, use your calculator. But when you have numbers in the denominator, that means divide. So I take 275 and I divide it by 100 and I divide it by 1,000. That's going to be 2.75 times 10 to the negative third. And that's going to be kilograms, because that's the unit that's left over that didn't cancel out. That's how it's all done. And this is considered a hard one. I'm going to leave that up there, and I'm going to put one on the board, and I want you to try it. So pause the video when we get to that point, and then come back on when you're ready to check it, and we'll see how you do. Try to pick a hard one. "14 gigaliters equals how many milliliter?" You do have to be careful how you draw or you write your letters. You have to really pay attention to the uppercase and the lowercase. So 14 gigaliters equals how many milliliters? Have your equation sheet, calculator, piece of paper. Stop the video right now. Go ahead and try that one on your own, and then come back when you're ready. Okay, so what you're gonna do is you're gonna take the 14, well, you're gonna notice, first of all, there's a prefix, there's a prefix. And that's liter now. It's not meter, it's not grams, it's not seconds, it's something different, but it doesn't matter because the prefixes are what counts. So you get your equation sheet realizing that, once again, this is gonna be 2 steps. Sometimes it's not 2 steps, sometimes it's just 1 step, but this one's 2 steps. So we've got to find the capital G equation that we're going to use, and we have to find the lowercase m equation that we're going to use. So when you look at your chart, you should see that it says 1 times 10 to the 9th meters equals 1 gigameter. There's the gig, that's the capital G. And then the other one we're going to use, 1 times 10 to the 3rd millimeters equals 1 meter. Those are the 2 you're going to use. Hopefully that's the ones that you chose to do. If not, stop the video again and try doing the rest of it this way. What you have to realize is these are the base units, and they can be changed to anything. And in this problem, they have been changed to liters. And so you're going to make your conversion factors out of those 2. So you do like you did in the first one. Take 14 gigaliters and stick it over 1. I can't go directly from gigaliter to milliliter. So the base unit is a liter, so that's what I'm going to go to. Liter goes in the top, because that's what I want to get for this part. Gigaliter goes in the bottom, because that's what I'm trying to get rid of. Just like before. If something is in the numerator and something's in the denominator, it cancels out. So then, this is the one I'm going to use first. That's the one that has gigaliters in it. So in front of the liter, I put 1 times 10 to the 9th. In front of gigaliter, I put a 1. That's going to make the gigaliters cancel out. Now I can go from liters to milliliters. So I'm going to use this one second. I'm going to use that one second. So I'm going to put milliliters in the top, because that's what I want to get. And I'm going to put liters in the bottom, because that's what I'm making cancel out this time. And then I look at the numbers. There's a 1 in front of the liter. There's 1,000 in front of the milliliter. and that's gonna make that cancel out. And now I just do the math. Everything is in the numerator, that means I multiply. 14 times 1 times 10 to the 9th times 1 times 10 to the 3rd is 1.4 times 10 to the 13th. And that's gonna be milliliters. I hope you did it right. I hope it worked out. If not, there's always Wednesday tutoring.